Thank you very much for having me. Yes, I'm an architect. I'm trained as an architect. I'm heading the digital design unit in Darmstadt. And together with my colleague, Professor Ulrich Knark, we explore the field of additive manufacturing in architecture since now 10 years. And we at one point thought it's good to broaden the term architecture more towards the built environment. So BE, built environment, and additive manufacturing, this is what we are looking at. And we do this in form of an exhibition that you find here if you go to the ground floor of Hall 11, E49. You will find pieces from architecture and construction exhibited there. And tomorrow we will host a symposium in the Portal House. And you can tomorrow find this book there, which tells a little bit more about people presenting their work. So, this is our cover for the BEAM Symposium and the exhibition. And as I said, we do this since 10 years, which led to a book where we collected interesting examples of build project, of research work, and I could almost continue with what my previous speaker was talking about, because we have a project which deals with printing on the moon, where the architecture office Foster and Partners from London is speculating about not maybe the material qualities, but what it takes to create a habitat for humans on the moon. But besides that, we invited quite a lot of authors to present and discuss their work in our book. If we think about 3D printing, then it mostly appears to be a completely new topic, but you find precedents already in the 1930s. William Urschel is suggesting to print what he calls an Eskimo house with a 3D printing method, and they actually prototyped that. William Urschel, 1930s. There's a bit of manual labor involved here, as you can see, but the process reminds of current technologies in the built environment. It didn't take off in the 1930s, and it didn't take off in the 1990s when Benko Koźniewicz filed his first patent on what he calls contour crafting. When I saw these images, I thought building a 3D printer that is larger than the house you want to print, does that really make so much sense? We will see that it actually happens these days. It didn't happen in the 1990s, it didn't happen in the early 2000s, and in our book we explore why it happens now, and we use this slightly cheesy quote from Victor Hugo: "You cannot resist an idea whose time has come." And what we mean by that is to turn ideas into successful and maybe even disruptive technologies is an extremely context-sensitive process. So place, time, resources, and parallel innovation in adjacent fields need to fall together to ignite such an innovation. If we look at additive manufacturing and architecture, it's the digital design, it's the 3D modeling, it's the parametric modeling that needs to come first. So instead of drawing buildings, you 3D model them. And this then is in a digital process chain then transformed into the movement data, into the G-code for the printer. So there's a digital continuity from ideation to fabrication. You need to have the machines, and for large-scale elements in architecture, you need robots to increase the reach for building large-scale elements, and you also need innovation in material. If you look at concrete and concrete that is used for 3D printing, then you have to make sure that it is fast. It needs to cure fast enough so that the additional layers that are piled up on top of each other don't destroy what's underneath. But it should not cure too fast because one layer needs to be connected to the next one, so you do not have any delamination. So there's quite a bit of material science involved in 3D printing and architecture. So robotics, digital design, material science needs to come together to start the process. And then suddenly it's there. It's the company Peri that is 3D printing a multifamily house, and you see it's the 3D printer that is slightly bigger than the house that is printed here in a kind of monolithic fashion. So they proved me wrong. And if you look at this gantry system, it's not such a big of a technical infrastructure to make it happen. What's the result? A very conventional multifamily house. So we could now discuss what else is possible if we 3D print architecture, but this was not the question for this project. Here, Perry asked, what happens if we 3D print a house? Do we get a permission from the authorities to print it? Can we interface the 3D print with all the other elements that need to go into a building, like a window, like the plumbing, electricity? And this is what they explored in this project successfully. There are other approaches that use 3D printing to explore, for example, the interaction with the built environment and with the context. What you see here is a project by the University of Hong Kong. Lydia Ratoy, she was presenting that last year on our Beam Symposium, and John Lee. And what they did here is they disassembled an existing wooden barn, and then they 3D printed a new structure. They created new spaces where they kind of printed around the existing structure, and once the print was there, they re-erected the wooden structure so that the new is combined with the old. And here I think you see the strengths of creating bespoke and geometrically very precise elements that allow to combine what is there with what could happen in the future. If you 3D print, then with concrete you always have the challenge that when the element is exposed to tension forces or bending, you need steel reinforcement in the concrete. And it's not so easy to integrate that in the 3D printing process. So the team around Philip Block from the Block Research Group came up with a design proposal for a modular bridge which has a shape that leads to pure compression forces in the system. And if you only have compression, concrete is fantastic to deal with that. And so let's say the limitations that come from the process and the material here become a design driver of what could be a bridge and what is also a very beautiful sculpture. If you want to integrate reinforcement, well, then there are other means, other ways to use 3D printing. What we look at here is a floor slab. Under production, you see a lot of steel along the trajectories where you have a lot of tension forces, and you see these elements below the steel, and these are actually 3D printed cassettes made from concrete developed at the TU Graz that act as a kind of void between the parts that are then cast in concrete. So if you look at a floor slab from underneath, you can see that you have conventionally cast concrete in the rib structure, and you have these cassettes that are 3D printed. And it looks interesting and beautiful, but it also saves up to 35% of concrete because it's left out where you don't need the material to make that a structurally sound and spanning floor slab. Can you start maybe the video? It's not starting automatically. This is research done by Professor Harald Kloft at the TU Braunschweig, and they used a very well-known technology called shotcrete, where you shoot the concrete. They take such a nozzle and connected it to a robot, and now they are shotcreting to build building elements. Like here we can see the column, and Harald Kloft in German presents this technology as Drucken mit Druck, printing with pressure. And what's interesting here is that you can now interface a 3D print with pre-installed steel reinforcements. So this is one possible way to solve the challenges around reinforcing 3D printed structures. The team tries to develop hybrid methods where you use maybe a regular fabricated, very thin floor slab. There are very efficient ways how to do that. And if you need additional elements to take additional loads, then you maybe 3D print the ribs on top of these standard building elements. But we all know that concrete is very CO2 intensive, so ideally we get rid of the material. We use more alternative materials in architecture. And there's the company WASP, which is also here with their own booth in Hall 12 with an exhibition piece in our exhibition here in Hall 11. And what they are exploring is using local earth to print buildings. They printed what they call the Tekla house technology and clay. And again, clay is a material which is very weak in bending and in tension. So the architects had to come up with a design which is a compression-only structure that actually looks a little bit like a cactus. If we go back one more image, they of course explore new technologies, new local materials, but they also explore the spatial qualities that emerge out of these kind of funny little shell shapes. WASP works a lot together with an architecture school in Barcelona, the IEC, and here students learn the limitations but also the potential of the material of the process, and then they speculate what that could mean for architectural design. And I think that's a very rewarding approach to first know your limits and then explore what's possible within these limits. And beyond maybe the pavilions or these cactus-like buildings, they develop solutions that we might use in the city, like this multi-story clay-printed building, where the shapes respond to the needs of the material and the process. You can, of course, fire clay and you can glaze it. This is what Studio Rap did for a project in the Netherlands. They 3D printed three-dimensional tiles, which they then glazed. And with this glazing layer, you have a very resistant tile that can be used as a facade system. Susie Payne from the Royal Academy in Copenhagen explored 3D printed clay as a kind of ornamental enclosure for steel elements, but they come with a second use. They could work as a fire protection for steel elements and buildings. And yeah, she's very much inspired by Baroque and gives this Baroque inspiration a new expression through the use of 3D printing clay. So what's next? You can see what's next when you come to our symposium tomorrow in the Portal House. We start at 9:30, and we can see that 3D printed buildings are getting bigger and bigger. This is one under construction that Klaas de Rijke from Bollinger Grohmann Ingenieure will present tomorrow. And this is just one building of quite a few that will be built here in this U-shape configuration. And we see one other detail when we look at this plan. 3D printing is used for those parts that are complex in geometry, and then there are other parts of the building complex that are built in a more conventional way. And this is something which is very necessary to make AM an established technology in architecture, to identify where we have benefits from it in the fabrication and in the building. AM is scaling up, and if you go to the ground floor, you will see one of these columns that forms this Tor Alva, designed by Benjamin Dillenberger and Michael Hansmeier. It is currently under construction. It's a weird kind of a building that is also a research project, but a research project, of course, in one-to-one that explores not only technology, but also new formal expressions that are possible through 3D printing. You see, it is under construction now, and you get an idea of the scale of this tower. We need to deal with waste, and this is what the new RAW, a team based in Amsterdam, is doing. They are shredding plastic waste, and they use it to build urban furniture out of that. So it's a kind of upcycling process in a resourceful way. And we have Urban Reef in Rotterdam, and they look at questions of cohabitation. We all talk about climate change. The extinction of species is a challenge that is at least as big as climate change. And Urban Reef is proposing to create habitats for animals in the city. And they are even proposing to include the seeds of plants in the 3D printed clay, so that maybe construction and plants are kind of merging together here. What are we doing in Darmstadt? We are currently exploring this. This is a piece. It's lightweight 3D printing, where it's not a solid filament that is extruded here, but it's actually a tube, so it's hollow. And with this hollowness, we are able to create stable but very lightweight elements. And we are currently, maybe you could start this movie as well. We are currently working on changing the air pressure within the extrusion nozzle to allow for a change of cross-section of these 3D printed profiles. This is what I wanted to show you. This is what happens AM in the built environment. This is a photograph from our exhibition downstairs. And please come to our symposium. You can register here on our website, beam.de. Thank you very much.
Thank you, Oliver. Fascinating stuff. Any questions from the audience? I appreciate it is the end of the day. Yes, sir.
Thank you very much for the wonderful speech. My question is, you have shown us wonderful round design houses. Like Hundertwasser said, I don't like straight lines. And so is it possible to make such houses within an eco-village where living, leisure and working is integrated for, let's say, 100 persons, maybe all creative jobs like designers, architects, musicians, artists, like creative Silicon Valley. And so could that be a part? Houses from Lehm, from straw, from Ziegel, from green beton, made by this production. Could you imagine such a model project, and who would make a feasibility study and maybe invest? Thank you very much. Sustainable everything.
That's a very large question, and I'm not sure if we can answer them by looking merely at the technology. But I think what's interesting is that there was a strong interest in clay and straw buildings in the 1970s. There's great work being done at the university in Kassel. And we kind of got lost of that, and it's reviving now through digital technologies, which is surprising. But it happens. If you see the work of WASP in Italy, where there's really the ambition to take local materials, to not drive something for hundreds of kilometers, so you save a lot of CO2. You need to make sure that your machines work with this local earth. So this is happening. If you ask me who invests in that, I'm not a business person, so maybe you find people here that are interested in that. Maybe on the symposium.
Okay, thank you very much, Oliver. Thank you for the presentation. Thank you all for watching. Thank you for the AV team and the Back of House team. That brings us to the close for today. So you have 1 hour to scoot around the show, see what's new, maybe go downstairs and have a look at what's going on at TU Darmstadt. And then we're back here in the morning from 9:30. Thank you very much.
Thank you.
Thank you.